Good morning, everyone. Thank you for joining today's EAC webinar. This is Cassie Stumo. I'm the marketing specialist here at EAC. Today we will be talking about Mathcad Creo integration and how you can use them together to optimize your design process. We will begin today's session with an intro of EAC from Shannon Wilson, one of our EAC Mathcad experts. And then PTC's Mathcad specialist, Andrew Leedy, will be taking over. The session is being recorded. Unless there are any technical difficulties, everyone will receive a replay after the webinar. And then please send over any questions you may have, and we'll answer them after the presentation. Shannon, I will pass things over to you.
Okay, great. Thanks. Good morning, everyone. Just like to start out today with just a quick overview of EAC for those of you on the call who may not be as familiar with our company and what we do. At EAC, we are dedicated to help companies transform the way they design, manufacture, connect to, and service their products. We do this by offering a wide range of products and services, including CAD, PLM, and SLM software, as well as desktop 3D printers. We implement the Internet of Things and augmented reality into business strategies, help with design and engineering projects, and offer training courses on topics such as Windshield, Creo, and Architects. I will now hand this over to Andrew, who will be discussing how Mathcad and Creo can work better together.
Okay, thank you, Shannon. Hello, everyone. My name is Andrew Leedy. I'm an application engineer here at PTC, and I will be going through a quick demonstration of Mathcad and Creo today and how they can work together. So before I talk about and go into the actual demonstration, I just have a few slides to go over just some very high-level information about Mathcad for anyone who on the call who might be unfamiliar with it or hasn't seen it in a while, so hopefully be a refresher for those people. So a little bit about the background of Mathcad, what are the challenges that we're hearing from our customers, and then we'll present the solution and then some of the capabilities of that. So one of those is that we just see a lack of standardized processes and tools to capture calculation in intellectual property. So in this case, it's going to be all about the engineering process. I want to be able to document what we're doing when I design something. I want to be able to have the calculations, the intellectual property, show how it works, basically all of that information in one location. Now, there are a lot of ways that a lot of companies are doing this today. Spreadsheets, different computer programs, just the classic pencil and paper, some manuals that we might have, but all of this is just spread out in multiple different sources and just really all throughout the company in different manners. So overall, we're just seeing limited sharing and reusing of calculations and intellectual property. It's very easy to lose some of this information when it's so spread out like this. And it's also easy to have to redo work. If I can't find something that's already been done before or someone on my team has already made something that I wasn't aware of, it's very easy to get lost in this manner. And we're also seeing that errors are very hard to catch, and this is something that's happening all the time. A classic example that we always use is this Mars probe, this Mars climate orbiter in 1998. Made it all the way into space, and then it just crashed because of the units. Half of the team designed in one type of unit, the other designed in another type of unit. So when it's all spread out and disorganized, we get these kinds of errors that could have easily been avoided. So that's the background in terms of where we're coming from with Mathcad. So Mathcad has been around for a while. The latest iteration of that is what we call Mathcad Prime. So it's all about analyzing, solving, documenting, and then sharing off the information in an easy manner. So it is at its highest level a digital engineering notebook to perform engineering calculations and where we can manage our design intent. So it houses all of our notes, the calculations, the plots for these different calculations, but it's not a computer program. It just basically combines the ease and familiarity of an engineer notebook with a powerful mathematical engine in the background. So it's just like an engineer notebook where we can have it as neat and as organized as we want, but also has that mathematical engine in the background where I can define variables, define equations, run through equations, and then keep track of everything at the end of the process. So it's very intuitive to use. So it has an easy whiteboard interface with natural math notation. So all we're writing on here is basically how I would write it down with pen and paper. X plus Y equals, X equals, whatever it's going to be whenever I'm defining variables. There's going to be no cells to keep track of and to be able to link up to. It stores all this. It's very intuitive. It's very comprehensive. It combines live math, text, graphics, and programs in a single readable format. So it has everything we need to do to both calculate and then also be able to document everything. Something that's also interesting here is that it's going to manage our units automatically as well. So it understands how to convert the units. So for an example, I can add inches and feet and then put the output as a default unit. Maybe I want them in inches or in feet. And if I go through, like for example, this pipe outer diameter, if I would change that unit on that to feet, it would automatically convert the number associated with that to its respective number in feet as opposed to inches. And then it's also self-documenting, so I can share this off. It can archive everything. It's very easy to keep track of. It's entirely WYSIWYG, so it's what you see is what you get. So as I go through and edit this document, I can do some things that I'm very familiar with like a word processor. I want to make things bold. I want to be able to move things around in a very easy manner, center a line, left a line, whatever it's going to be. It's very easy to get this document how I want it to look. In terms of how I can actually, bring in some other things, it has a very rich numeric function library. So I don't have to teach the system how to do a function and be able to store these off in like a master document. A lot of this is all built in. We have a bunch of different worksheets that you can get that has all these different functions already built in. So depending on what industry you're working in or what kind of equations you're working with, there's probably a worksheet that will go with it that has a lot of that stuff built in that you could pull from. And then in terms of some things that you can output here, different XY plots, polar plots, contour plots, complete control over how I want to be able to show this data at the end of the process. And the topic of conversation today is how it's going to integrate with Creo Parametric. So I can take variables, parameters, calculations, analysis, all of that stuff that I'm doing within Creo, take that and send it to Mathcad to run some analysis. And then I can send some values back to Creo to be able to drive things like annotations on here or parts of my assembly even. Overall, be able to just document the design intent associated with that. So I have a 3D model completely linked up to my Mathcad documentation. So going even further with that documentation process, making that link, making the link between the two different pieces here. So if I have a parameter in Creo Parametric, I can directly link it up to a parameter that is in my Mathcad workbook. Be able to have this as an analysis-driven design, so sending those values back and forth between Creo Parametric and Mathcad to produce that analysis-driven design where I can have this assembly actually being driven or parameters on my assembly driven from that math book, and also use it for verification and validation at the end. So if I change a value on either end of this, I can double check in both places to make sure that my design is still going to work. Maybe I'm checking for clearance of different parts in my assembly, but in my engineer notebook, I'm checking my stresses and making sure that this thing is still going to be able to perform in the manner that it was designed to. So now I have a demonstration I can show. This demonstration is actually going to have two parts. One is just going to be for people who might be unfamiliar with Mathcad. It's just going to be a very general Mathcad demonstration, just a few minutes. So anyone who has seen this before, this will look extremely familiar. Then we'll step into how it can actually integrate with Mathcad, with Creo Parametric. So first, just the general Mathcad demonstration here. So we're just going to start off with a general engineer notebook, and we'll go through, make some changes onto this, document some of the process, and then again, we'll step into Creo Parametric to take that a little bit further. So we'll start with a document that has already been started in this case. Now, the first thing you might notice, if you haven't seen this before, is it looks very simple. It looks exactly like a Word document or anything from another word processor. So it's entirely WYSIWYG. If I change the text color, the alignment, all of this is just done from that access ribbon, and then I can change that around to basically decide how I want this current project to look like and what I want the text to appear in. And then there's a bunch of different options in terms of how I can manage the page, and do I want to show grid or not show grid. Basically, it's up to me in terms of how I want to lay out this engineering document and how I want it to be displayed, and whichever is going to be easiest for me. Now we were able to do calculations from here, so that's the first bit we'll look at. Here we're going to be looking at a beam deflection problem. So not just writing in stuff and adding in equations, I can also add in things like pictures that I might be storing from other locations. So it's not just purely doing calculation work. It's all about just documenting the entire process here. And for that, I'm going to need a bunch of different things like these pictures, like all the equations written out, just documenting the process and doing the work that I typically would just be writing down anyway. Now I can put some math in. So it's working the same way, again, that I would work if I was writing it down by hand. So here we're just declaring and defining some variables. So B equals D equals, and then we'll use them in a calculation. So I can use this for I equals 1/12, and then B times D. Now, something interesting that it's doing here as well, and that we'll see in a second, is it's going to check my progress and my work as I go through and write this. So as I go through and say, what does I equal based off of those parameters, you're going to notice that I get kind of a funky answer. And the reason, and you can see the H is actually a little bit of a different color, that's because I had accidentally chosen a constant as opposed to using the D variable that I had gone through and actually written out. So we can see H equals, that's Planck's constant. So it went through and used that, and then eventually went through the equation and displayed my answer in that manner. So I can always just go back, fix the work that it's kind of flagged as being incorrect for me, and then I can see that now my answer is updated to something that makes a little bit more sense. Now I can add units to this as well. So it will assume default units. So as soon as we add a unit to B and D, it's going to go through and actually calculate it and give me the default unit in meters. But I can also go through that, change it to centimeters, and it even goes back and changes the actual number associated with that as well. So it's keeping track of all this. It's not up to me to make sure that I'm doing the conversion correctly. It's also going to go through and check for compatible units. So if I try to add centimeters and seconds, it's going to tell you that it has no clue what the heck to do with that. It's just going to say that is incompatible. You need to go back and check the work that you had done there, flag it with that big red square. Now, in some cases, we probably have data from elsewhere. So we have capabilities to be able to import and export from other systems or to other systems. So in this case, we can actually import an Excel file. So be able to reuse a lot of the existing data that we probably already have. You know, this we probably just want to be starting fresh with a lot of the work that we're doing here. So I have a bunch of different information that I want to be able to pull from that I've already documented and stored somewhere else before. So we can pull those existing rows and columns in from an Excel file. So it's going to read that spreadsheet, and then I can use those to drive different things. Like in this case, we'll just be driving a matrix variable, storing those rows and columns as a matrix that I could be able to pull and use in my in different equations. Now, this is live data, so I can always go through and change the range of that data. So change the rows and the columns that it's associated with, and it's going to go through, recalculate it, and define a new variable, new variables in my matrix. And then once it's defined, we can use those values to drive our overall equation. So now I'm looking for the Young's modulus of the selected material that we're going to be using in some further calculations. Choose a particular number from that matrix, give it a unit, and then go through and display that answer for me. So now my E is defined, and I would be able to use this in some calculations further down the road. So we have another graphic here. So I can always add in some more variables into my documentation. And it's going to look very familiar to what we did before. This is the typical process. You have a drawing, you have different variables. We're going to have some functions that are going to use those variables, and eventually we're going to get a final answer that is important to us. So we've defined everything that's going to be driving this graphic. We can put some values in for all this as well. And again, it's going to understand the units and be able to move those through the entire equation at the end. I don't have to keep track of what I had put in meters, what's going to be in centimeters. It just keeps track of everything. So it's very easy to find an answer to an existing equation that we've already written out. So if I go through, we have a particular Young's modulus associated with that. We have some of the new variables that we put in for L and A. I can go through and see my final equation for my deflection. And then maybe I just want to evaluate this at a certain number. But since we've already gone through and defined all the variables, it's all just about plugging that into the equation. So L/2 is where we're going to define this at, equals, and it's going to pull all the units that we've already defined and all the variables we've already defined to get me that final answer. And if I ever change that around, change to millimeters, it's going to be able to display that very easily for me. So now we can also look at something like symbolic derivation. So we have these expandable regions that we can use within Mathcad. This allows me to store some background information that might be driving some major equations in these certain areas. I might not want all of this in my final sheet. Maybe I just want the very high level information, and then some of the complicated work, just hide it behind the scenes. This is also where I would be able to store like intellectual work. So if I shared this Mathcad worksheet out with someone who I don't want to be able to see all of the intellectual property that I might have stored in my worksheet, this allows me to hide those areas out so you can't actually access them unless you have the right to, unless you've been given permission to. So it's very easy to consume this and always be able to expand that out if you need to see some of the background work. Now, the last thing to look at just in this the very general Mathcad demonstration here is just how do I make some different plots here. So all kinds of different plots that we can support, charts and graphs, basically how I want to display my information in an easier manner. I don't really have to worry about the equations driving these plots. Once I've created that link, It's all just about how do I want to change the look and the feel and the visibility based off of what is being changed. And these are live plots that will help me do my engineering. So if I ever need to pick on certain areas of this plot and be able to see, okay, what's the exact value of a certain area, I can be able to find that very easily. So that's a very general look at Mathcad for people who might be unfamiliar with it. But now we're going to take it a step further. We're going to be talking about, okay, now I have a worksheet that we want to be able to adjust a Creo assembly against. I want to drive a Creo assembly with this worksheet. So in this demonstration, we're going to be looking at that integration between Mathcad Prime and Creo Parametric. So first, we're going to look at the design that we're working with. This is a power transmission shaft, and the design is just about complete here. So I have the whole general look here. The power is going to come through my lower shaft, up through the gear set, out through the upper shaft, and then to the transaxle. Now there are 4 outputs that will be supplied for Creo, and we will be focusing on the shaft speed and the horsepower in this case. We have those just annotated on the design here, so it's very easy to see. We also have 4 different outputs from Creo, including my lower shaft inner diameter and its wall thickness that we will be computing using Mathcad Prime. So basically taking these values, sending something over to Mathcad, having that analysis and the mathematical engine go through and do some calculations for me, and then give me an answer in terms of what these values are. Because right now, they're just assumed values for this inner diameter and wall thickness. The wall thickness is eventually just going to be calculated based off of strength criteria of my lower shaft. So I can access Mathcad Prime by inserting a new worksheet from my application menu and then choosing a worksheet that we have already made before. Then once that is loaded, we can go review it. So here we can use Mathcad, just as we did before, to quickly define and utilize different variables that we have associated. The thing that's going to be different in this case is that I have input parameters. These are not parameters that I'm defining in Mathcad. These are being driven from somewhere else. These are being driven from Creo Parametric. So I have my in speed and my horsepower from Creo. Now, first thing to do, right now they're just dummy values. I want to assign them as inputs. I want to create the functional link between Mathcad and between Creo Parametric. So here I have 2 different inputs defined. It's going to give them an alias. So just basically giving them a suffix saying, suffix saying Mathcad. Now I could push those back to Creo. So now I can recognize that there's going to be some inputs that I now need to go assign in Creo Parametric. So we can do that through our relations menu. So the relations menu allows me to go see what input parameters I have. So we have all of my input that are the parameters that I've already defined in Creo, but now we also have some of the new inputs from within Mathcad. So I can see where is the source in this. It's not going to be a user-defined variable that I just made. It's actually coming from my Mathcad document. So here I have my in-speed Mathcad, my horsepower Mathcad. They have, again, assumed values. I want to be able to create the functional link between this and the same value within Creo. So whenever I change the value in Creo, whenever I change that annotation, it's going to push that value into Mathcad for me. So here we have my horsepower from Mathcad. I want to insert a relation and set that equal to the horsepower within my Creo assembly. And then once I've created that functional link, I have a value associated with horsepower and my in-speed in Creo. So once I've assigned them and updated this whole thing, I can go see that now my horsepower is going to be equal to the horsepower Mathcad, which means that this is going to go into my worksheet. It's going to go through a bunch of different equations and then eventually give me a final answer that I can use to drive this Creo assembly. So here the 2 links have been made. So now going back into Mathcad. So now again, I've created that functional link back into my Mathcad worksheet, back into Mathcad Prime. All we have to do is go through and update these units to be able to see what my new values are. Again, these are being driven directly from Creo. So the link has been made in this case, and I'm going to utilize these in a bunch of different equations to, again, eventually give me the final answer that I'm worried about, which is going to be the diameter of that lower shaft. So reading through this whole document, we won't go through every single bit of work that was done here, but again, this is just that typical engineering work that I'm going through and calculating all the different values I need until eventually I get to that final answer. So these are going to be my output parameters. So these are going to be values that I'm going to assign just as I did before. Instead of assigning it as an input this time, we're going to assign it as an output. So this is something that's going to be coming from Mathcad, and I'm going to bring it into Creo Parametric to drive my overall assembly. So we can save and push that just as we did before. That will allow me to go into Creo and recognize that change. So switching back there, back into our relation window, Now we can see one Mathcad output, and we can create a third relationship to make the output variable in Mathcad map to the parameter in Creo parametric. And then once I've mapped that newly mapped parameter will allow my Creo model to update because we were utilizing this parameter to actually drive that assembly. So here I have the output from Mathcad. We can set that equal to the inner diameter from within Creo parametric, just as we did before with the input parameters. So now refreshing, once again, it's going to verify that I've created the relationship, and now I can see that those values are equal to each other. Now back into the assembly, since I was using that value to derive the overall assembly, and I can see my annotation updated here as well, I can go through and just regenerate the assembly. It's going to go through, recalculate the different parametric features that I did to define this, and that's going to change my overall assembly to reflect that new inner diameter as well as the wall thickness that's going to be associated with it. So as I change that inner diameter, my wall thickness is going to keep being updated as well. So now we can go through this a second time. So this is, I don't want to just be able to check one value and verify that. I might want to check a range of values. So here we're going to increase the shaft speed to 3,800, and we're going to increase the horsepower to 600. And maybe we know that these values are within our operating boundaries, and I just want to verify, is it still going to work on the Creo side? But more importantly, is it also going to work on the Mathcad side as well? I want to be able to check and verify on both of those ends to make sure that this product isn't going to fail in any way, not just in terms of a design, but am I going to reach some sort of failure as I run through these calculations? So back into Mathcad, we can update those two input values that we did before just by going up there to the ribbon and saying update values. And it's going to push that 3,800 and 600 into my Mathcad Prime worksheet. Then do the same business we did before, go through that whole document, calculate, and give us a final answer, which is going to be that output based off of the new values that we placed in. So we're going to save and push this, then switch back to Creo. And then after regenerating, we're going to see that the shaft design is going to visually change based off of the new inputs and outputs that we were testing out. So this allows me to not just check one bit of work, but continuously go through and refine my design and have this just be completely analysis driven and linked up to the calculations in Mathcad. So here's my new inner diameter and wall thickness reflected in my current design. So now we'll run through this one last time. So very similar flow to how we did our second run. This time we can actually maintain some of the values, but we can utilize our annotations to also be able to update these changes. So since our input parameters are directly tied to these annotations, if we go through and type in a new value from this, we don't even have to go to the relations menu to do any of this work. I could just do it directly on my annotations because of that connection. So now I have the new shaft speed. I can regenerate the model, see what work it was done in Mathcad once again, to be able to see and visualize the changes that we had. So we can go back into our inputs. We can update those values to be able to be reflective of what was currently in the model. And then we can save and push the changes once we verify that the diameter is going to be okay, send that back to Creo, and overall change that assembly once again. So I hope this brief demonstration helped you gain an understanding of the integration between Mathcad, Prime, and Creo Parametric. The integration is allowing an engineer to capture not only the form and the fit and how the design works and make sure that clearances are okay, but also check for the functional behaviors of their design. So you're taking expert knowledge from your Mathcad document, from your Mathcad worksheet, providing it to the actual design team and being able to have them leverage this design or leverage this in their design and allow them to be a lot more efficient than they were before. So now, just to recap on what we saw here. So the whole goal of Mathcad is to provide value to you. So how can this provide value? Prevent loss of IP and improve knowledge capture. So keep everything just organized and storable. Overall, just be able to optimize our design and keep this more closely linked up to the whole engineering process. So take that and work with analysis-driven design that's going to be linked directly to my calculations. Don't just keep them in separate realms because they're both, it's critical that both ends of this work, that the design looks good, that it works, that it's all coming together properly, but also that the back end of this, that it's actually going to be able to function in the real world. Overall, be able to improve the product quality, know unit screw-ups, understand what variables are going to be driving our design in the end. overall just be able to speed up our time to market. So the system writes out those equations, mitigates the screw ups for us, keeps track of a lot of the work that I'm doing every day, all day, and overall just be able to also improve my compliance with regulations. Documents can be stored and showed to everyone, whether they're going to be internal or external auditors. So that's that very high level look at Mathcad and the Creo integration that we offer with that. Now we do have a few testimonials. I won't go through and read all of this, but we have a lot of large companies out there utilizing Mathcad and Creo together. So Honeywell, B&W, there are a few companies that are utilizing this, and we have some of these testimonies on our website as well. So if you're interested in reading any of those. But otherwise, with that, that's all I have for my demonstration. I'll pass it back off to Shannon.
Great, thanks so much. Just wanted to quick mention, we do have a promotion going on right now for limited time, offering buy two, get one free on all new seats of Mathcad. This is also available for seats of Creo as well. If you have any questions, please feel free to reach out to Jenny or myself. We'd be happy to assist you further.
Awesome. Thank you, Shannon. I don't see any questions. Thank you, Andrew, for that presentation. Hopefully that gives those of you on the call an idea of what it looks like to use Creo and Mathcad together. If not, and you still have questions, please reach out to Shannon or Jenny if you have any, and then, or you would like to take advantage of the buy two, get one free deal on Mathcad licenses. You'll be receiving the recording of the webinar shortly. And you can find upcoming webinars on eacpds.com/events. Or if you'd like to see any previous webinars to date, you can go out to eacpds.com/webinar-replay-library to watch them. Thank you again, everyone, and have a great rest of